Alright, ladies and gentlemen, welcome back to this Athenian Stranger tutorial video where today we are going to continue our discussion of solving systems of equations by learning how to do so using something called the substitution method. So I'm going to read these two rows here out loud, and I want you to write these things down. So the substitution method is defined as a method of solving systems of equations by substituting equations within one another. The substitution method is a method of solving systems of equations by substituting equations within one another. Let's get that written down. And there are three principal steps that are involved in solving a system of equations using substitution. Step one is to solve one equation for x or y. And then once you solve one of the equations for x or y, in step two, you substitute this expression into the other equation and solve for the variable. In step three, you substitute your answer into the revised equation from step one and solve for the other variable. So these steps, the way they're written out here, it makes the process sound more complicated than it really is. What you're going to do is make sure that you solve one of your equations for one variable, either x or y, and then you're going to plug that into the other equation and solve for the other variable, and then you'll be able to figure out what the original variable is by plugging that answer in. It's a pretty straightforward process. Best thing to do is to work examples, and you'll get the hang of what substitution is all about. So let's move down the page a little bit to our example section. We're asked here to solve each system by substitution. And this first example is, it kind of gives a false sense of security about what you're supposed to do. Here you see that we have both equations solved for y. So y equals 4x minus 1 and y equals 2x minus 5. Okay, well, if we're following our steps here, we've already solved one of the equations for x or y because they're given to us solved already. So in this example, step one's already done. Now we have to substitute one of these expressions for the other variable. So what I mean by that is that if y equals 4x minus 1 and y equals 2x minus 5, then basically 4x minus 1 equals 2x minus 5. You could think of it like the transitive property of mathematics. So what we're going to do to solve this system is first set these two equations equal to each other by writing 4x minus 1 and set that equal to 2x minus 5. Okay? And so now we're going to solve for x. This is where we solve for the variable. So we'll try to gather our x's on the same side of the equation. I'll try to gather them on the left side of the equation. And what I'll do here is subtract 2x from both sides. On the right side of the equation, 2x minus 2x leaves behind 0. And on the left side of the equation, 4x minus 2x leaves behind 2x. And now we just have to bring everything down to a new line. 2x bring down that minus 1, equals, now the only thing on the right side of the equation is that negative 5. So 2x minus 1 equals negative 5. And in my continuing efforts to isolate the x variable, I have to add away this 1. This negative 1 plus 1 on both sides. Okay, negative 1 plus 1 is 0. So that kind of cancels out. And I'm left with 2x equals negative 5 plus 1, which is negative 4. Okay, and what that means, if I divide both sides by 2, I can get x by itself. These 2's cancel. And I now have x equals negative 4 divided by 2, which is negative 2. So x equals negative 2. Now we've got x. Okay, remember the solution to the system is going to be a coordinate pair, x comma y. Well, I've got x. X is negative 2. Now I just need to find y. And to do that, I'm going to plug that negative 2 back into one of my equations. Doesn't matter which one. So I'll just choose the top one. Y equals 4x minus 1. Okay? Now everywhere I see an x, I'm going to put in a negative 2. So I'll write y equals 4. And here I have to multiply by negative 2. So I'll do open parentheses negative 2 minus 1. So continuing to simplify here, 4 times negative 2 is negative 8. Negative 8 minus 1 is where I'm at right now. And the final step, negative 8 minus 1 is negative 9. Okay, so now I have that other component of the solution. I've got the y component. So the solution to the system of equations is negative 2 comma negative 9. And previously we learned how to solve these by graphing, and had you graphed these two equations on a coordinate plane, you would see them intersecting at negative 2 comma negative 9. Okay. Let's do example 2. Okay, now example 2 gives us more of a flavor of what substitution is all about. Remember, step 1 was to solve one of the equations for x or y. Well, once again, step 1's already done for us. We're given that y equals 6x. So here's where the substitution part comes in. You see this x right here? I'm going to plug in this, or you see this y right here? Y equals 6x. So where I see this y, I'm going to plug in 6x. Let me show you what I mean by that. We have 2x plus 3y equals negative 20. So I'm going to write 2x plus 3, and then I'm going to stop and put an open parentheses, and then I'm going to put in what y is. So you see this is y right here, but y equals 6x. So instead of writing y, I'll write 6x, because I just want one variable in my equation that I've got to solve. And that equals negative 20. Okay, so now we're going to do a new line. 2x plus, and now I need to distribute 3 to 6x. 3 times 6x is 18x. 2x plus 18x equals negative 20. And now I just add 2x plus 18x to get 20x. 20x equals negative 20. And now to get x by itself, I just divide the top and the bottom by 20. Cancel out those 20s, get x by itself. X is equal to negative 20 divided by 20, which is -1. So remember, our solution will be x comma y. So I have the x value now at -1. I just have to find y. And what I can do now is plug this -1 back into either of my equations and solve for y. The easiest will be the first equation. So we'll choose y equals 6x as the equation we're going to evaluate x at, or evaluate y at. So now, if y equals 6x, then y also equals 6 times -1, because x is -1. So y equals -6. And that completes that one. So the solution to the system is -1 comma -6. If you had graphed these two equations, they would cross at these coordinates. Okay, let's look at number 3. Here we're once again given that y equals x plus 9 and 3x plus 8y equals -5. So what I'm going to do is recognize that step 1's completed for me. I've solved the equation for x or y. I have x plus 9, and I'm going to plug x plus 9 where I see a y in my second equation. So here's what that looks like. It's going to look scary at first, but it really isn't. We'll write 3x plus 8, open parentheses, and then whatever y equals, we'll put inside the parentheses. So y equals x plus 9, so we put in x plus 9, close parentheses, equals -5. Okay, so we have 3x plus, now I have to distribute, multiply 8 through this expression. 8 times x plus 9 is 8x plus 8 times 9, which is 72. And that equals -5. So now we're just going to combine these like terms. 3x plus 8x is 11x. So I have 11x plus 72 equals -5. Well, I'll subtract 72 from both sides. On the left-hand side, these cancel out, and I just have 11x equals, and now what I basically have to do is I've got -5 minus 72. You're really just adding 72 and 5, putting a negative sign in front of it, and that's -77. Final step is to divide both sides by 11. Cancel out the 11s, and you get x by itself. X equals -77 divided by 11 is -7. So x equals -7. Here is our solution that we're building, x comma y. And I've got the first part, which is x is -7. So now I just have to plug that -7 back in where I see an x in one of my equations. The easiest one is this top one, y equals x plus 9. Now that I know what x is, I can solve for y by setting y equals to -7 plus 9. Okay, and -7 plus 9 is +2. So the y value is 2. The solution to the system is -7, 2. Again, if you graph them, that's where they cross. Okay, let's look at number 4. In number 4, we're given a problem that's already solved for x, and then we're given a mixed equation here. So instead of plugging in for y, we'll plug in for x. So I'm going to use the second equation and plug in the first equation. 2, open parentheses, and I'm just going to plug in everything right here. 4y plus 7, close parentheses, minus 6y equals 12. See, what I've done is I've plugged in what x equals in the first equation into where the x value is in the second equation. And now I only have y letters here. So I'm going to solve for y. I have to distribute this 2, that's 8y plus 14 minus 6y equals 12. Okay, and we can combine these y values here. 8y minus 6y gives me 2y. So now I have 2y plus 14 equals 12. Subtract 14 from both sides. And we get 2y equals negative 2. Dividing both sides by 2 gives us y equals negative 1. Okay, so we found y this time. Remember, we have a solution to our system, x comma y, and we have found the y value at negative 1. So now I just have to plug that into one of my equations, and I'll use the first one. Since I'm looking for x now, I'll say x equals 4 times negative 1, because I'm substituting in now negative 1 for that y. See, x equals 4y plus 7, so x equals 4 times negative 1 plus 7. Let's continue. X equals negative 4 plus 7. And now I have x equals 3. Okay, so there's the full solution, 3 comma negative 1. All right, so we'll now flip the page, flip it over, look at the back. Now in number 5, we're presented with an issue. We don't have either of our equations solved for any of the variables. So we have to solve one of the equations for a variable. And we'll solve the top equation for y. Let me show you what I mean. Over here in side work, we're going to solve 2x plus y equals negative 2. We're going to solve that for y. Okay, that's that top equation right there. So the first thing I'll do is subtract 2x from both sides, getting y by itself, and now y equals negative 2x minus 2. Now that I have one of the equations solved for y, I can plug in negative 2x minus 2 into the second equation wherever I see a y, and I can solve for x. Okay, so what this looks like is we'll write 5x plus 3, and now I'll do an open parentheses, and I'm going to put this entire expression in here. Negative 2x minus 2 equals negative 8. Okay, and what I'm going to do is solve for x now. So I'll just rewrite the first part, 5x plus 3, or plus, now don't write 3, 5x plus, and now I have to distribute this 3 through this little expression here. So 3 times negative 2x is negative 6x. 3 times negative 2 is negative 6. And that is all equal to negative 8. Okay, so further simplification, 5x minus 6x equals negative x minus 6 equals negative 8. Add 6 to both sides. And you have negative x equals Negative 8 plus 6, which is negative 2. We're going to multiply both sides of the equation by negative 1 in order to get rid of these minus signs. So basically changing the signs. If negative x equals negative 2, then x equals 2. Okay, so x equals 2, and that is, we've now solved one of the missing variables. We have found x. Okay, so remember our solution will look like a coordinate pair, and our x value is 2. So now we just have to find the y value. We can plug that into either of our equations here, and so I'll plug it into the top equation. I know what x is, so I'll use this top equation and write 2, open parentheses, 2, close parentheses, plus y equals negative 2. Okay, 2 times 2 is 4, so now I have 4 plus y equals negative 2. And I can subtract 4 from both sides, getting y by itself. Y is equal to negative 2 minus 4, which is negative 6. So 2 common negative 6 is the solution to this system of equations. All right, let's do this thing all over. Let's do it again. We're going to extend this line here. It's our side work area off to the left. We have the same problem in number 6, where I don't have any equations solved for a single variable. It's actually going to be easier for us to manipulate this second equation to be solved for y, because you see how y doesn't have a coefficient. It's going to be easier. So we'll pick that second equation and we'll solve it for y. 2x plus y equals 9. So first I'll subtract 2x from both sides. Get y by itself. Y is equal to negative 2x plus 9. And now I can substitute what this is, what y equals, back into my other equation. So if y equals negative 2x plus 9, everywhere I see a y, I can put negative 2x plus 9 and solve for x. So I'll take that first equation, 2x minus 3, open up the parentheses and put this whole thing in here, negative 2x plus 9. Negative 2x plus 9. Close parentheses, equals negative 11. Okay, now we have to solve for x. So we'll rewrite the first part, 2x minus. Now I have to distribute. 3 times negative 2x is, 3 times negative 2x is negative 6x. Notice the double negative there. And 3 times 9 is 27. Plus 27. Okay? I see I'm making a mistake. we have to consider this as a pair. Okay, we've got to keep it bonded. So what this is going to look like is when I distribute, let me explain. So when I distribute negative 3 into the equation here, I'll have negative 3 times negative 2x, which gives me negative 6x, and then negative 3 times 9, which gives me negative 27. Okay, so my completed equation on the left side is 2x minus 6x minus 27 equals negative 11. Now, I'm pretty sure it would have worked the way I was doing it, but I just want to follow the way that I've been teaching you to do it. Okay, So let's keep working. 2x minus 6x is negative 4x minus 27 equals negative 11. Now let's add 27 to both sides. Okay, they cancel out on the left, and we have negative 4x equals negative 11 plus 27. Okay, and here I've got to figure out what that is. So 27 minus 11, a little side work, is negative 16, or positive 16 rather, because I'm adding 27 to negative 11, and I'll come out with 16. Divide both sides by negative 4, and I get that x is equal to negative 4, because 16 divided by negative 4 is negative 4. And now I'm seeing where I've taken my attempt to simplify this problem and I've made it in much worse. So back here on line 2, when I multiplied negative 3 times negative 2x, this should have been positive 6x, and then I would have had 2x plus 6x, which would have given me positive 8x. And what I would have done down here is I would have been taking 8x equals 16, and I would have divided by 8. Okay, giving me 16 divided by 8 would be 2. Sorry about that. I should have just trusted the way I was doing it. Okay, so x equals 2. Now, if x equals 2, we can find out what y equals by plugging in 2 everywhere we see an x in one of our original equations. Doesn't matter which one. So now we're going to go back to one of our original equations, and I'm going to choose the second one because it's going to be the easiest to solve for y. And I'll plug in a 2 everywhere I see an x. So 2 times 2 plus y equals 9. 2 times 2 is 4, plus y equals 9. Subtract 4 from both sides, and you have y equals 9 minus 4, which is 5. So the solution to the system is 2, 5. Again, sorry for that error. Okay, let's look at, let me see what else is left here. Graphing versus substitution. Okay, right. Okay, let's skip 7, 8, 9, 10, and 11 for now. Okay, I think we get the idea, right? I want to show you this comparison now between graphing and substitution method. Okay, and I'm not going to do number 1 because it's too easy. We're going to do number 2. They are, you see how we're given the exact same equations? Yeah, we're given the exact same equations, and we're going to practice doing both methods. First we'll graph, and then we'll do substitution. Okay, so if I'm going to graph these lines, the first thing I have to do is get each one in y equals form. Now this is going to require some extra space because I have to solve each equation for y in order to I have to get them both in slope-intercept form. So first I'm going to write really small, I guess. 5x minus y equals negative 5. Okay, I'll subtract 5x from both sides. Okay, and I'll have negative y equals negative 5x minus 5. And I can just change all the signs and write y equals 5x plus 5. I got to do the same thing for the second equation, and that's where I think I'm going to run out of room. So I'll do the second equation up here since I'm not going to work this first problem. I'll do 3x minus 6y equals 24. Okay, first step is to subtract 3x from both sides. And I've got negative 6y equals negative 3x plus 24. And now I'll divide every single term by negative 6. Giving me y equals 1/2 x minus 4. Because negative 3x over negative 6 simplifies to positive 1/2 x. And 24 over negative 6 simplifies to negative 4. So these are my two equations, y equals 5x plus 5 and y equals 1/2 x minus 4. Okay? And so what I'm going to do is I'm going to use this as my system and graph these two lines on this coordinate plane. So here I've got 5x plus 5, so I'll go up 5, up 1, up 2, up 3, up 4, up 5. Okay, there's my y-intercept. And I have a slope of 5, so that means I'll rise 5, run 1. So starting at that y-intercept, I'll go up 1, 2, 3, 4, 5 over 1. And I'll also go back to that y-intercept and go down 5 to the left 1. Down 1, down 2, down 3, down 4, down 5 to the left 1. Okay? It might help to do it again. So let's go here and go down 1, down 2, down 3, down 4, down 5 to the left 1. Now bring in your straight edge and graph in that line. You should be noticing one of the difficulties of the graphing solution, which is just lining it up is a challenge. We'll use a different color for the second equation. I have y equals 1/2 x minus 4. So I'll start at negative 4, negative 1, negative 2, negative 3, negative 4. And then I'll proceed by going up 1 over 2, because my slope is 1/2. Up 1 over 2, up 1 over 2, up 1 over 2. And I'll go the other way. Down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. Okay? Let's bring in that straight edge and draw a line. And we see that they're crossing right here. So where are they crossing? Well, that's negative 2 on the x and down 1, 2, 3, 4, 5 on the y. So the solution, according to the graphing, would be negative 2, comma, negative 5. Now let's solve using substitution properly. So what we're going to do is go over here and solve one of our equations for one variable. For example, we'll solve this top equation for y. Okay, remember we already did that over here, but we'll do it again. We have 5x minus y equals negative 5. Subtract 5x from both sides, and you get negative y equals negative 5x minus 5. Okay, change all the signs, and you get y equals 5x plus 5. And what we're going to do now is substitute this 5x plus 5 everywhere we see a y in the second equation. So I've got 3x minus 6, open parentheses, and we'll put 5x plus 5, close parentheses, equals 24. Okay, and so we'll write 3x, and now I'll distribute this negative 6 straight through the whole thing. So negative 6 times 5x is negative 30x. Negative 6 times 5 is negative 30. And that equals 24. Okay, so 3x minus 30x is negative 27x. Minus 30 equals 24. Divide both sides. Oops, I went too fast. Almost skipped a step. Before we divide both sides by anything, we're going to add 30 to both sides. Okay, and that gives us negative 27x equals 24 plus 30, which is 54. And now we're going to divide both sides by negative 27. Giving me x equals negative 2, because 54 divided by negative 27 is negative 2. So what I've found is I've found the x component. I've got x equals negative 2, and now I just need to find the y component. I've got to plug negative 2 back into one of my equations, which I'll do up here. I'll use that top equation. 5, this is 5x minus y equals negative 5. So I'll write 5, open parentheses. Instead of writing x, I'll write negative 2, close parentheses, minus y equals negative 5. Okay, so 5 times negative 2 is negative 10, minus y equals negative 5. We'll add 10 to both sides. And I have negative y equals negative 5 plus 10, which is just 5. And just change the signs, okay, because it's negative y equals 5, then y equals negative 5. Okay, so negative 2 comma negative 5. The good news is we found the same things in both of our examples here. Okay, so we're at 38 minutes, and what I think I want to do now, let me flip. Let me flip back to our other page here where we were working through all these, and we'll try to, I think I'm just going to leave it there. I kind of want to do another one, but we're right at 40 minutes. If I have time in class, I'll work another problem. If not, you've got this video as a reference. Just here on number 7, if I can at least get it started. I guess I can always just shut the video off if we run out of time. So I have here x plus 5y equals 4, and 3x plus 15y equals negative 1. So I'm going to solve this for x. X equals negative 5y plus 4. You see what I did there? I subtracted 5y from both sides. And now I'm going to plug that in to my second equation. So I'll write 3, open parentheses, negative 5y plus 4, close parentheses, plus 15y equals negative 1. That gives me negative 15y plus 12 plus 15y equals negative 1. Yeah, this is good that we're doing this because we're going to get something that doesn't make sense here in a moment. So watch what happens now. I have negative 15y plus 15y. Those cancel out, leaving 12 equals negative 1. Okay, now here's the deal. That is not true, right? That is not true. 12 does not equal negative 1. Therefore, this system has no solutions. Okay, so this is very important. This system has no solutions. In fact, if I were to solve, just to prove it, if I were to solve the other equation, I would find out that they both had the same slope. So these are parallel lines. This is a parallel lines. Okay. All right, well that is substitution. It's an introduction to substitution anyway. And you have a homework assignment that goes with it. And what you're doing is you're doing exactly the same thing you did we did in this video. Okay? So you've got 16 problems to do where you solve using substitution, where yesterday you solved using graphing. So good luck with that. And we'll pick up tomorrow learning a new method called elimination. Okay, this is the elimination method coming up tomorrow. But that'll be enough for today.